So comets. Comets travel in elliptical or parabolic orbits. They reach the outer edge of the solar system and maybe beyond. Halley has a 76-year orbit. It reaches beyond the planet Neptune. It passed close to us in 1986. The next time is in 2061. It's called Halley's Comet because Edmund Halley was the first person to understand comets were in orbit around the Sun, and the first person to predict the return of any comet. In 1705, he used the theory of gravity to predict the return in 1758 from reports on comets in 1531, 1607, and 1682. He actually never saw it return. He died 16 years before it did. However, it did, so it still bears his name. More recently, we've had some spectacular comets like Hale-Bopp at the top and Hyakutake at the bottom. Neither of these comets, which were visible at one time, will ever return in our lifetime. Some pictures of Hale-Bopp, and we can see how large it is across the sky. It was actually quite visible, and we could see there's this blue tail and this white tail, which we'll talk about in a second. Hyakutake was in 1996, and it was also a very brilliant with a large tail behind it. Pan-STARRS is a comet which came by in 2013. It was actually visible in the night sky by the moon this March. You can see it here above the Washington Monument. It's very small in this, so it's kind of hard to see, but at night, it's still close to the sun at this point, we could see it. Now the structure of a comet has a tail. It's a narrow column of gas and dust, and that tail can stretch over 100 million kilometers. The coma is extremely rarefied gas atmosphere that reaches to about 100,000 kilometers around the nucleus. The nucleus is a dirty snowball, roughly 10 kilometers across, containing most of the comet's mass. Now, the Giotto spacecraft was sent to the Halley's Comet to determine the nucleus density, and the density was about 0.2 grams per cubic centimeter. So that comets are fluffy material. It's not a compact, solid piece of ice. It's pieces of ice and snow that have gathered together in the outer solar system. The nucleus was odd-shaped, and it had dark, which is carbon-rich material, gas that was coming out in jets as it heated up around the sun. So this picture shows us a little bit better. We have the tail, which goes off behind the comet. We have the head of the comet. Inside we have the hydrogen envelope, then we have the coma, and then we have the nucleus. The spectra of coma and tail shows comets are rich in water, carbon dioxide, carbon monoxide, and small amounts of other gases. Evaporating water is disassociated by solar ultraviolet radiation, creating a large hydrogen cloud around the comet. And repeated passage by the sun eventually erodes the comet's gas production ability. Now, where do comets come from? Most comets come from the Oort cloud, which is a spherical shell of trillions of icy bodies believed to lie far beyond Pluto's orbit at a distance of about 150,000 astronomical units. This picture shows this spherical distribution of the Oort cloud, and inside we see the Kuiper belt, and we have the orbit of Neptune. So typical comet orbits come well outside this, go in past the sun, and come back out. Now, originally orbiting among the giant planets were planetesimals, and comets were tossed into the Oort cloud by these planets. The shape of the Oort cloud is determined from observation of comet orbits. Some comet orbits seem to come from the flatter, less remote region, the Kuiper belt, which extends from Neptune's orbit. Comets in the Oort cloud are very cold, about 3 degrees above absolute zero, and only warm up enough to emit gas when they enter the solar system. Essentially, when they pass Jupiter and are closer to the sun as Jupiter, they start to give off gas and they become visible. So how do they come out of the Oort cloud? Well, the sun's gravitational attraction pulls it and it causes it to be in an orbit. So perhaps this was the original orbit of the comet. and something happens, a supernova shockwave or a passing star, or two objects come too close to each other. And when that happens, it causes it to either slow down or something happens and it falls into a new orbit that goes close to the Sun. And what do we see in the comet's tail? Well, as it gets warmer by the Sun and pieces and parts start to come off, dust particles are struck by photons and are pushed away from the Sun. So solar photons, which is the same thing as sunlight, exerts a pressure on these and causes them to be pushed away. We call that radiation pressure, and it drives emitted cometary dust into a dust tail. A second tail, called a gas tail, is created by the interaction of the comet's emitted gas and the solar wind. Since both the solar wind and solar radiation move away from the Sun, comet trails always point away from the Sun. The gas tail is blue, the dust tail is white, and the dust tail points directly away from the Sun. The gas tail moves off to the side because these are all objects in orbit around the Sun. The further they are away, the slower they go, and so the gas tail tends to get pushed off to the side just due to the differential rotation around the Sun. So if we look at a comet's journey, it comes in, gas begins to evaporate, and a coma forms around it when it's 3 astronomical units from the Sun. The tail starts to form, and so the tail is always pointing away from the Sun. After it goes around the Sun, the tail is still pointing away from the Sun, and eventually all this material goes off. The stuff close by may refreeze on it, and as it gets far enough away, it's no more materials coming off, and it goes back on its orbit. Now, most comets seen on Earth are one-time visitors, meaning they have periods of thousands or maybe millions of years. A small number of comets have periods less than 200 years, and they're called short-period comets. And repeated passages around the Sun eventually deplete the comet of all of its icy material. Short-period comets are now believed to be icy nuclei from the Kuiper Belt. And support of this comes from the detection of many small icy bodies orbiting near or somewhat beyond Pluto. Statistical analysis indicates that the Kuiper Belt may have a total mass far greater than that found in the asteroid belt. Typically, one can see a meteor in the clear dark sky about every 15 minutes. And most of these meteors are fragments of asteroids or comet debris that arrive on the Earth randomly. Meteors seen at a faster rate, one every few minutes or less, and that all come from the same general direction, are called meteor showers. Here's a time exposure of a meteor shower that seems to be coming from this point in sky. The point in sky that all of them seem to be coming from is called the radiant. A meteor shower is a result that a comet is filling its orbit with emitted dust, and the Earth passes through that dust-filled comet orbit. So the Perseus meteor shower comes from the orbit of an old comet, and that orbit is filled of debris from past trips around the Sun. And as the Earth comes by, then this orbit material comes in and it appears to strike. And it strikes actually just before dawn. Usually meteor showers are good from 2 to 4 a.m. And they all appear to come, in this case, from the constellation Perseus. Meteor showers are typically named after the constellation where the radiant is located. The Perseid meteor shower, the radiant is in the constellation Perseus. Comets burn themselves out and eventually die. Alternative fates are to crash into the Sun or into planets. Comet Shoemaker-Levy broke up and actually hit Jupiter in 1994. We couldn't see it because it hit on the backside of Jupiter, but we see here the scars as different fragment pieces hit Jupiter. The scars were visible for a very short time until they eventually faded away.